Finding food, the art of foraging. By the end of this lecture, student will be able to explain the biological and the ecological principles underlying foraging behavior, describe adaptive feeding strategy, discuss optimal foraging theory and energy trade-offs, apply ecological insight to feeding management in domestic and captive animals. To eat is to engage with the world's most ancient problem, how to find, capture, and consume energy before energy consumes you. From the spider patient trap to the cheetah's sprint, every creature has evolved a strategy. Yet feeding is more than instinct, it's intelligence in motion. A crow dropping a nut onto a root is calculating risk and reward. A cow grazing calmly in a field is balancing intake with digestion. Understanding these strategies means designing feeding systems that respect natural motivation systems where animals can behave as they were built to behave. Every organism must eat to survive, yet in nature food is neither constant nor easily obtained. Ethology examines feeding as a behavioral system, integrating perceptions, movement, decision making, and sometimes cooperation or competition. The foraging challenge energy economics at its core. Feeding is an energy optimization problem. Animals seek to maximize net energy intake per unit for time or effort. Time, distance, predation risk act as constraints. This summarized by the optimizing foraging theory OFT, which predict that animals behave to achieve the best energy trade-off. Profitability equal to energy gained divided by time, risk, and effort. Profitability equal to energy divided by time plus risk plus effort. Example: Lion balance hunting large prey, high reward, high risk with smaller, easier kills. Hummingbird choose flowers with the highest nectar return per visit. Domestic hens prefer food patches that yield a constant return with minimal movement. Foraging strategy and adaptation. Different species evolve instinctive feeding strategies built to their niches. Predator rely on stealth, speeds, and sensory precision. Cheetah explosive pursuit optimized for short distance. Spider passive ambush using whips as energy saving tools. Owls silent flight and actual hearing. Grazers and browsers adapted for continuous feeding on abundant but low quality food. Cattle and sheep exhibit rhythmic grazing cycle governed by gut fill and rumen fermentation. Behavioral management, pasture rotation, feeding frequencies mimic natural foraging rhythm. Scavengers exploit unpredictable available resources. Vultures use soaring flight and social cues to locate carcass efficiently. Omnivores display high behavioral flexibility. Pigs, bears, humans adjust diet and foraging technique seasonally. Cognitive and social dimension of feeding. Many animals exhibit intelligent foraging. Crows drop nuts onto roots for cars to crack open. Chimpanzee use stick to fish termites. Honeybees communicate food location through the waggle dance, a classical case of symbolic communication. Social species may cooperate or compete. Wolves and lions coordinate group hunts. Chicks establish feeding hierarchy, pecking order. In domestic herd, dominant individual often monopolize feed unless space and resources are managed equitably. Feeding behavior in domestic and captive animal. Ethological insight direct inform animal management. Feeding enrichment stimulate natural foraging. Puzzle feeder for primates. Scatter feeding for poultry. Preventing stereotypes. Boredom and feeding restriction can cause repetitive behavior like bar biting, shame chewing. Feeding times. Aligning feeding schedule with natural rhythm reduces stress and digestive disorder. From a veterinary standpoint, understanding feeding motivation help diagnose welfare issues, malnutrition, behavioral pathology, evolutionary implication. Feeding behavior is a driver of adaptation and diversification. Geostructure, digestive physiology, and even social organization evolve around. In ecosystem, feeding link energy flow between tropic level, the behavioral foundation of ecology itself. Quizzes. Optimize foraging theory predict that animal will maximize energy intake without considering risk. Randomly search for food to avoid predator. Maximize energy gain relative to time, risk, and effort. Feed only during daylight. Maximize energy gain relative to time and risk and effort. Which of the following is an example of social feeding behavior? Solitary hunting in tiger, group hunting in wolves, filter feeding in whales, grazing in isolation. Group hunting in wolves. Cognitive foraging behavior is best illustrated by a cheetah chasing a gazelle, a cow grazing continuously, a crow using traffic to open nuts, a fish following a scent trail, a cow using traffic, a crow using traffic to open nuts. Cognitive foraging behavior. In domestic system feeding, enrichment aims to increase feed conversion efficiently only, mimic natural foraging and reduce boredom, replace natural diet with processed feed, eliminate social interaction during feeding, mimic natural foraging and reduce boredom. In domestic system, feeding enrichment aims to increase feed conversion efficiently, mimic natural foraging and reduce boredom, replace natural diet with processed feed, eliminate social interaction during feeding, mimic natural foraging and reduce boredom. Wise understanding natural feeding behavioral important in animal management to promote welfare and prevent abnormal behavior, to eliminate feeding competition entirely, to increase dominance hierarchy stability, to reduce energy expenditure to zero, to promote welfare and prevent abnormal behavior. Practical activity comparative foraging observation to analyze difference in feeding behavior between species and the management system. This objective of this activity, comparative foraging observation, objective to analyze difference in feeding behavior between species or management systems. Observe two species, two group of the same species under different feeding condition, free range or confined. Free range versus confined. Record feeding rate and duration, social interaction at feeding, evidence of exploration of frustration, calculate average feeding time per individual, interpret data in light of optimal foraging principles. Discuss which environment better support natural feeding motivation, what behavioral signs indicate stress or restriction, how can feeding design improve welfare and productivity. Feeding behavior is shaped by energy, economic, and ecological context. Wrap up key takeaways. Feeding behavior is shaped by energy economics and the ecological context. Optimal foraging theory explain decision making in resource acquisition. Social and cognitive factor modify how animals obtain and share food. In domestic system, feeding must respect species-specific motivation. Ethological insight into foraging improve welfare, efficiency, and behavioral health.